Hi, my name is Jane Paek. I'm the Solutions Architect Manager for Redis Labs. So we are sponsoring this event, and they have asked me to talk about a topic that is relevant to the type of discussions that we have with our customers. So just to give you a background, as a solutions architect, our team talks to numerous different customers about different types of use cases where they want to understand how do you use Redis. What do they want to do with Redis? And a lot of times the conversation comes to, well, I could do this with a single open source Redis database, but how do I scale it? And what does that concept mean to scale Redis? So I thought, okay, let's talk about scaling Redis to 1 million ops per second. And it may sound like a lot, but one of my coworkers, he totally trumped me. And he did a presentation yesterday about how to scale Redis to 50 million ops per second at less than 1 millisecond latency. So if you get a chance, you could visit his training video from yesterday about how he goes about scaling that. Okay? So that's the topic for today. I have 20 minutes. I'll go through the agenda, but just to level set, how many of you have used Redis? So why are you in this class? Okay, how many of you have used clustered Redis? Handful of you. How many of you have actually configured a clustered Redis versus using it via a hosted provider? So who's clustered Redis manually before? Oh, so maybe you should be up here teaching this class. So all joking aside, what I'm going to cover is this is talking about Redis from what is Redis, a shard, how do you describe the Redis database itself, and then taking it up a level in terms of, what are the concepts around clustering and partitioning? If you take a look at a lot of the presentations they covered, they talked about the Redis open source clustered API, but there's many different ways in which you could cluster Redis, and I'll discuss some of those strategies, okay? We'll also get into some patterns and anti-patterns to scaling. Some things that work very well on a single Redis instance or Redis server process does not work well in a Redis cluster. And then we'll get into tools for benchmarking, Memtir benchmark, Redis benchmark. There's some pretty cool announcements that were announced this morning with the keynote. And I'll try to do a demo for my 1 million ops per second in a 3-node instance that I have deployed on EC2, and some resources available for you to review on just getting to know Redis. Okay? Hopefully I could cover all of that in 20 minutes. All right, so let's level set the conversation about Redis, because I hear this time and again. There's a lot of misconceptions about what is a Redis instance versus what is Redis server process, what is a shard. So in general, the three are equivalent. When you talk about a Redis instance, it's that one server process that you could run on your Docker container or on your MacBook or on your huge EC2 instance or your huge GCP instance. So that is a single Redis server process, and you could also call that a shard. Now, the concept of the shard doesn't really apply for a single process Redis database, but it is considered a shard. Okay? So when we have these conversations about Redis and sharding, what we're really discussing is taking that concept of a Redis database with the entire key space that it has. I think it's 2 to the 32, around 4 billion keys that you could house in a single Redis server process. And how do you scale that to handle even more keys and leverage more CPU and probably get a lot better latency and a lot better throughput? Okay? So in general, Redis, it's 10 years old now. You have a bunch of clients, be it running in Kubernetes or your JVMs or wherever. They all point to a host name and a port. Okay? And you could talk to it. It has the protocols. And you're using your client libraries for Python client library or C or Java. So those client libraries, you pass it the host name and the port, and it talks to a backend Redis server process. Okay? And so that's a shard. Okay, so in this example, I have one Redis server process running on a node, and your application talks to Redis, and it's represented by a host name and a port. Now, what do you do in Redis? What can you do with it? Anyone know how many data types or data structures you could currently deploy in Redis? Okay, quick quiz. How many of you have used a hyperlog log in Redis? Just right, actually, I think I see 3. Hyperlog log to me is like one of the coolest data structures in Redis. 12 kilobytes of memory, but incredibly fast and efficient at giving you a cardinality of the different elements that we're able to count, right? So that's one data structure. How many of you have used any of the geo-indexing in Redis? Right? Or a couple more people. So geospatial indexing allows you to just pass it a latitude and a longitude and something into the index, and you could start asking radial questions about, I'm here, find me who's closest to me. And if I recall correctly, Lyft uses that algorithm where as you drive around, the drivers update their locations, and I'm in San Jose at the airport. I'm like, hey, tell me the closest driver around me that you could route me to. It's a classic use case, right? Or tell me where the nearest pharmacy is. So there's a lot of different data structures that you could do even within that one single Redis server process. And so these are the gamut of different things that you could use within Redis. Very popular are the things like strings, and you could use counters, but sets, sorted sets, hashes, lists, and the new ones is streams that's come out. So Redis, as that one single process, could do a lot. And you could also load modules, like we had discussed this morning, about how do you make it into a search database? Or how do you make it into a graph database, or make it into an AI or an ML module, right? The ability to process these things. So you got familiar with Redis, you love using it, and you realize, I need to scale. And sometimes that decision may require you to completely re-architect your application. Okay? Because depending on how you've written your application, if you thought that you were happy to, as a startup company, you go with a small little Redis server process, it works great, but then you need to scale. If you don't understand how you scale Redis, it could have a dramatic impact on the way your application has to get redeveloped. Okay? So in terms of what can you do with Redis? Let's play around with the typical web architecture space, right? We talked about the different data structures. You could put Redis and use it as a string for all of your caching needs. Session caching, image caching, profile caching, data caching. You could cache almost anything in Redis. You could then go into user sessions with hashes, individual keys to identify all the different subfields. You could use the lists and the sets and the pub/sub elements for a lot of your job queues, and actually streams is a great play in this space. You could use a search module, make it into a search engine, super fast. You could extend Redis into RAM with some of the Flash extensions from Redis Enterprise. And you could also do streams and pub/sub, JSON storage, numerous different things that you could do with the multi-property of Redis. Okay? So now you're ready to scale, right? How do you scale Redis? It's a pretty broad question. And you'll notice that there's a consistent pattern to a lot of the presentations here about different ways in which they decided to approach that scaling. And a lot of it is still dependent on how you're using Redis. If you're using it as a key value store, very basic key string with no transactional requirements at all, then it's actually pretty easy to scale Redis by sharding. If your application uses a lot of multi-execs, waits, or you're accessing certain keys and they need to be accessed at the same time, those types of requirements, you need to rethink how your application is designed, okay? So having said it, here are all my clients. That's a blue. I need to access my Redis server processes. In this example, I've sharded into 4 different ways. So 4 server processes. And just for simplicity's sake, I've divided it into 4 different servers. Okay? So how do you choose which one of these servers you should point your client to? So there's different options that you could take. Okay? So one example is to let the client logic decide which one of these nodes, which one of these shards you talk to. Your client application, you write the Python or Java code where you define a lookup table to say, for keys with ranges from A to G, I go to shard 1 or node 1. For keys from H to 0 or H to O, I go to node 2, and so on. So your client has to be smart enough to know exactly which key belongs in which shard, and you access it. The great thing is, right, there is no network overhead. You just do a quick lookup, and you know exactly where to find your key. The trouble comes in when you start having to move around your keys, or you have to reshard your logic, right? And once you start doing that, something has to update the lookup table, and it becomes cumbersome. And once you start getting into high availability, master-slave concept, and knowing which ones to point to, it gets a little bit tricky. Having said it, I've seen this as an excellent strategy for people who want to scale PubSub. So how many of you have used PubSub before? Okay, some of you, a lot of you. So a single Redis server process, once you start chucking tons of like PubSub updates and so on, it gets constrained. And to be honest, even the Redis clustering architecture is actually, I can't even say it's great. I could almost say it's actually potentially worse on handling PubSub. So by leveraging a client-based sharding algorithm to partition your different PubSub channels, you could really scale out PubSub in this mechanism. Okay? So it works great on this front. The alternative way is to go through client-side sharding still, so the client still has to know which shard it needs to talk to. But the logic behind which shard it goes through is kind of spread out and managed by hashing the keys. Okay? And so the most popular one that a lot of people talked about is the concept of the Redis clustered API. And the concept is you take a key, you apply a CRC16 or a bucket, basically create 16,000 buckets, and assign the buckets that go through like a mod whatever number, so in this case mod 4, to determine which one of these nodes or shards own which buckets or which slots. Okay? So that's what's behind the hash with query routing, where you take a key, and so in this example, I get A, and you're like, the client says, I need to get A. That's a command that it executes. And so the first thing it needs to do is, well, what is the hash slot that that key A belongs to? And that hash slot, if you go through a cluster key slots command, you'll find that that slot's to slot number 15,495. So then you figure out, OK, if I do a mod 4, I identify which node it belongs to, and then you connect to node 4 to get key A. The great thing is, even though it is client-side sharding, you don't have to write all of this logic. A lot of the client libraries already know how to support Redis clustered API. So when you're working with the cluster database, you enable it for the clustered API, and it now knows, oh, you're asking for key A, I'll slot you to node 4. And if you're asking for key A and all of a sudden key A is changed, it will actually update you to tell you that it's moved to node 2. And then the client library will go to node 2 to pick up that data. The nice part about this design, by the way, is that you're still taking away this middleman. Even though you calculate for this key, for this slot, which node you have to go to, that gets processed very quickly in your application layer, and then it knows directly which node to go to for your key. So if you want speed, this is still the fastest way to get access to the Redis data. Clustered API, go directly to the server with the shard that houses the data. Okay? So the third option is to go through a proxy-side sharding. And what that does is you have the clients, and they talk to the proxy. And from the client view, the Redis database still looks like a single Redis server process. It's a host, it's a port, and it grabs the keys that it wants. Okay? So the proxy handles the expertise to know which nodes have which slots. So the client just says get A. The proxy does the hashing, knows which one of these shards it needs to go to. It gets the data and passes it back to the client. Does this look familiar? This is some of the new initiatives that are coming out with Redis. Okay? So the proxy layer, some of the advantage that it provides is that what if these nodes move? What if you have to do maintenance? What if you have to change the IP address? What if you have to add a node, remove a node, do all the stuff that you have to do from a maintenance standpoint? It's great from an application view that, hey, it's just a Redis database. But underneath it, somebody at the operational side has to consider how do you patch it for security, how do you patch it for all the OS updates, how do you do the rolling, if VM dies, and how do you replace something else, right? So the advantage of the proxy is that it gives you a little bit of separation from the client to the underlying infrastructure or the database so that you have the maneuverability for the operational efficiency. Okay? The one thing, though, is that you could immediately see the proxy could introduce additional latency. So depending on the type of deployment that you have, if you have a proxy as a whole separate layer, a whole separate server, then you're introducing client to server and then proxy server to the underlying shard. So there's a couple of additional network hops that are around it. You could potentially house the proxies into the same nodes as where the shards live, and that could minimize some of the overhead. But ultimately, if you have these shards spread across multiple nodes, there are still hops that need to happen for the proxy to talk to all the shards and then return the result set back to the client. Make sense? All right. So in terms of the Redis enterprise deployment, in general, we use a proxy because it allows us the operational efficiency to balance things. But we also get the advantage of doing something called a multi-tenancy on the database deployment. So with multiple nodes in a 3-node configuration, I could have a logical Redis database, database 1. It has 2 master shards. It has 2 slave shards, so it allows us for failover. And I could create a separate database that's just a single master database. And I could create a third database, which is just a single Redis server process with 1 slave, 1 replica. Okay? So you could play around with the way your database or your application shards are placed. And as long as you specify a port and change the port for the different shards, you'll be able to configure it in this fashion. Okay? But you have to manage the deployment carefully if you don't have a proxy layer that accommodates on top of that. All right, so normally I pause and say, any questions? Nope, okay. So a couple of things that we tend to see, in terms of scaling, things that help you scale, things that really don't help you scale, right? So do's use pipelines. Pipelines allow you to send a bunch of commands to Redis. Redis processes it and then returns it back to you. But it does not lock the Redis server process for the entire time that you're sending 1,000 gets to Redis. Okay? And you're overcoming some of the network calls that's involved if you had to do a single get, set back and forth to Redis. So pipeline is a great way to actually optimize the calls that you have into Redis as long as you're not looking for individual transactional updates. Okay? Use unlinks versus DELs. How many of you are familiar with unlink? Okay, great. For me, it's been very effective. When my customers ask me, hey, Jane, our deletes are taking forever, or part of our process is that we flush the database at 12 o'clock midnight, and that flush all takes 5, 6, 10 minutes, right? So if you do something like a flush all async, it basically says, OK, we're going to disconnect the key name versus the key value. So from the application standpoint, my Redis is flushed. I don't have any keys. But in the background, if you actually monitor the Redis memory use, you'll actually see it slowly taper off. Okay? So that helps in terms of just manage. And so the same thing applies to deletes versus unlink. Delete breaks the connection between the key name versus a key value. So it's much faster of an operation, especially if you have large keys. Okay? And by the way, having a key that's 250 gigs in Redis is not a good idea. I have seen it. It is not a good idea. And if you try to delete a key that's 250 gigs in Redis, it's going to take a very long time. Okay? So the other thing is, Redis works well for, and people define it as small keys. The definition of small, I think, is kind of like loosey-goosey. Some places, they say small is less than 10 kilobytes. Others, small is less than 100 kilobytes. Some customers have keys that are 1 megabyte. Like, it's whatever works for you, right? Whatever works for you for the type of throughput that you want. But don't expect super bleeding fast performance if you have keys that are 30 megs, right? And you want to have like super high throughput through Redis at the latency that you want. Okay, so, and then the other one is understand the time complexity of the commands that you're issuing, right? How many of you have gone to the Redis IO commands page? Thank you. Okay, thank you. How many of you noticed the time complexity section when you look at the commands? Great. Okay, so every Redis command will have a time complexity section. Well, it will tell you whether this is an expensive call or not. Best one is O of 1, right? Great, we know exactly where the key is. But once you start getting into things like the sorted set, the Z range by, give me all the 100 million entries that you have in your sorted set, that's a very expensive call. Really, really expensive. You're not going to get great benchmark results out of that one. Okay? So just be careful. Look at the time complexity of the command that you're issuing. Even if you have a huge sorted set, if you just pop the topmost scoring element, fast. Versus if you want the topmost 100,000, could be slow. Okay? If you need to have keys that belong together, just make sure that you use a curly bracket or your custom hashtag so that they all belong to the same shard. Actually, this doesn't really impact scaling per se, but this will definitely impact how your application behaves, because you're just going to get errors if you're trying to do a multi-exec on a bunch of keys that are supposed to be together, but they're actually spread across multiple shards. Because all the commands for Redis still apply at the shard level. Actually, for Redis clustering, it has to be at the slot level. So if they are violating, if they're not in the same slot, then you're going to get errors. Okay? And the other thing is monitor for slow log. As you're benchmarking Redis, especially if you're benchmarking your own applications, take a look at the slow log to see if things come up. By default, Redis will start writing the commands that are longer than 10 milliseconds into slow log. And in the grand scheme of things, 10 milliseconds is pretty fast. But in Redis scale, it's slow. So take a look at the slow log and see if there's things that automatically get caught. I've worked with many customers where we look at the slow log as part of their deployment or QA testing. And some things that pop up a lot is key star. So I'm switching to the be careful section, where it says, be careful of running key star in production or in your application in general. It's a very, very expensive call if you have lots and lots of keys. Very easy to do in deployment, but really you should be using scan. Okay? So be careful. I think I mentioned already, be careful of the sorted set queries. Some of the persistence choices that you may have, RDBs versus AOF, especially if you're persisting from the master shard, could be expensive. Okay? And then caching keys without TTLs, especially. So you have two choices on how you manage memory in Redis, right? You could define TTLs for keys, where you say, hey, let's call it the key name, right? The key's name is name. I'm going to set the TTL for 30 seconds. And after 30 seconds, it's going to expire. Great. And then there'll be some background processes which are going to slowly clean up the memory for the keys that have expired. Well, what if you don't set the TTL for the key? And you've defined your Redis size to be 10 gigs. And it grows and grows and grows, and everything's great until, uh-oh, you hit the out-of-memory error, or you set an eviction, and all of a sudden it starts to evict keys, and that eviction process is more expensive than doing a TTL. Okay? So just these are some of the things that you should consider. There's so much more on how you tune and benchmark Redis, but these are some of the key things that we end up dealing with when we work with our customers. So top benchmarking tools, Memtier benchmark created by Redis Enterprise. You could download it. If you want to take a picture, you could see where you could actually download it off the Git. Really, what I like about it is that it does get set. It's super fast. It's a quick and dirty way of just assessing the health of Redis. And this has been something that we've been using a lot. Okay? And I'll be doing a demo on using this one. The other one is part of the Redis distribution. Is called Redis Benchmark. And I actually like this one when I start working with customers to better profile their environment. And the reason is this. I mean, it has the traditional stuff like you specify the host and port and password and things like that. But the main thing that it does is, I mean, it does do testing for pings, sets, gets, INCRs, lists, sets, hashes, and MSETs, and so on. But the part that I really like about Redis Benchmark is that you could define the type of calls that it's going to run as part of your benchmark. And this was hugely helpful for us when we work with our customers because one customer had an mget with 1,000 elements in it. And they wanted to benchmark if they ran that for X number of times, what type of throughput and performance should they see in Redis? Okay? And some of the cooler stuff that's coming out, hopefully with Redis 6, is the fact that it's going to be able to support the open source cluster. So now you could launch it by the way, Memtier and Redis Benchmark, as it stands today, could only benchmark against a single endpoint or a single Redis server process. It doesn't allow you to benchmark the cluster. Okay? And so the new version is going to be out, which is going to be really nice to really benchmark the Redis cluster. All right, so let me do a quick demo. I'm over my time. Are you OK with a couple more minutes? Cool. So let me switch over to my browser. So I have 3 instances running. You see 2 instances. And in this example, I have an open source Redis database running. Oh, can I switch over? You're wrapping up? Can I turn my computer? OK, thank you. It won't take long. All right, so let me add a Redis database. And I'll just call it RDB. We'll create a 10 gig database. I'm not going to enable slave. I'll make the port 10,000. And let me activate. Stay on this page. OK? So I created a Redis database. Here's the endpoint. And I'm going to launch a load against this. So let me. Launched, great. So in this example, and this is what's pretty impressive about Redis. This is a single Redis server process where, is it running? Yep. I mean, I'm literally pushing 600,000 operations per second, but its latency is around 3 milliseconds. Okay? And you could see that we're literally pegging the CPU. It's at 100%. And I'm running Memtier benchmark on this example, right? And so you could say, well, hypothetically, if I did shard this database, if I wanted to cluster it, what type of performance would I get? I'm going to change this so that I will cluster it and divide up that one shard into 4 different shards. Update. So in the background, we're taking a copy of the original shard, making 4 different copies of it, figure out what the hash slots are going to be, partition it, and then start redirecting the traffic from the proxy, right? So now, ta-da, 1.4 million ops a second at less than 1 millisecond latency. Okay? So this is the advantage of clustering or sharding. You get much better throughput and much lower latency. How you go about doing your clustering and sharding is up to you. Okay? So from a resource standpoint, again, my name is Jane. And you could go to home of Redis Labs /get started. That's going to give you lots of resources on downloading content. Redis reference, Redis IO. And the last thing I really want to push is we have new classes starting on April 16th on introductory classes to Redis data structures, Redis for Java developers, Redis search, and Redis streams. Okay? Thank you for coming. Really appreciate your time.